is Merryn Jose, and you're listening to MerlianPodcast.com. We have the pleasure today of speaking with Dr. Dean Radin. Dr. Radin is Laboratory Director at the Institute of Noetic Sciences in California. He worked at AT&T Bell Laboratories and GTE Laboratories on advanced telecommunications systems. And for nearly 2 decades he has conducted research on psychic phenomena in academia and in 3 Silicon Valley think tanks. At SRI, he served as a scientist on a highly classified program investigating psi phenomena for the U.S. government. His book, The Conscious Universe, won the 1997 Book Award from the Scientific and Medical Network and has been translated into 8 languages. The majority of Dr. Dean Radin's professional career has focused on experimentally probing the far reaches of human consciousness, primarily intuition, gut feelings, and psi phenomena. Dr. Radin's new book is entitled Entangled Minds. So welcome to the show, Dr. Radin.
Thank you very much for asking me.
It's a pleasure. Your latest book, Entangled Minds, is one of the most interesting, informative books I've read on bringing psychic phenomena into the realm of the normal as opposed to the paranormal. In the book, you write about the new reality. Can you explain what the new reality refers to?
The new reality here refers to the fabric of reality as seen by modern physics. And I call it new because, in a sense, it is referring to the old reality, which is common sense. Now, common sense, of course, has changed over the years, but most people have a kind of gut feeling about what they mean by a common sense reality. What they mean is that it appears as though objects are separate in both space and time. We don't find objects somehow coexisting in the same location, and nor do we find that things seem to be slippery in time. So that common sense feeling, which is what our senses tell us about the nature of the world, in many ways has been formalized into classical physics. We think of Newtonian Cartesian physics as classical physics, and most of it is a kind of mathematical encapsulation of common sense. The new physics includes Einstein's relativity, both general and special relativity, and quantum mechanics. And both of those new physics have radically changed the fabric of reality as we understand it. And it's not simply a theoretical change. It's a change that has been verified again and again. In fact, most of the modern world's electronics are dependent on quantum mechanics. So we know those theories are better ways of looking at the world. And yet it is so different than common sense that most people really haven't paid much attention to it.
That makes sense. Psychic phenomena such as telepathy, precognition, clairvoyance, clairaudience, psychokinesis are known as psi, which is spelled PSI. What is the derivation of this term for our listeners?
The term psi was chosen by a British physicist named Robert Fowlis in the 1940s, I believe. And it's part of a long tradition in parapsychology, which used to be called psychical research, and today also is called either sometimes anomalous cognition and other euphemisms. About every generation, the scientists who are working in this field rename it. They give it a euphemism. And the purpose is to get away from the entertainment taint that these phenomena invariably get.
Right.
So in the current generation of scientists often will use the term anomalous cognition as a neutral description of what we're dealing with in such a way that it becomes palatable to other scientists. Because I know as a scientist, if I write a paper saying I'm testing clairvoyance, it won't be published anywhere except in parapsychology journals, and even there, they would prefer the word psi.
So can you tell me how this relates to Entanglement, which is your latest book, Entangled Minds?
Entanglement is a property that was predicted from the mathematics of quantum theory. It predicted that an object, a quantum object, which, by the way, is all objects, any material object is quantum, but an elementary quantum object is best described in terms of waves of probabilities, as opposed to a single particle. There are no particles in the quantum world. There's only waves of possibilities, probabilities. That being the case, if you describe a more complex object that may have several apparent pieces, it actually is thought of then as a superposition or as a collection of waves. And given this way of thinking about objects, if two objects interact at some point, then what happens is that their waves combine. And as we know, with water waves, that waves can interfere. They don't eradicate each other necessarily, but they become a yet more complicated wave. And so if two elementary particles, say, like two electrons or two photons, interact, when they interact, their wave description simply becomes more complicated, which now includes both of the particles. And the curious thing is that, according to the mathematics, that when the particles then separated, the objects separated, their wave function never separates, because the wave function actually is not even in time. It transcends time, which means that the particles remain connected in some way. Now, that's what the math predicted, and Einstein didn't like this, and that's why he used the phrase, it sounds like spooky action at a distance.
Yes, the famous phrase.
But it has been tested repeatedly since the 1960s, and found that in fact, that when particles separate, there is some aspect of them that remain connected, and it remains connected instantaneously, which means that it appears to transcend time in the sense that we usually think of it. Some people think that the connection between the particles are faster than light. Others say no, it's actually an instantaneous connection. And one way of thinking of it then is that as the mathematics had predicted, when two particles interact, they are no longer two particles. They're actually one particle. And they can appear to be in two places at the same time, but in fact they're really not.
It's fascinating. We know that humans have extended capacities such as precognition and remote viewing, which you've studied for many years. And of course the question is, how can it be proven scientifically?
Well, that's the question, isn't it?
It is.
So there's two ways of answering that question. One is that you simply do empirical tests to see if you can verify claims. Someone claims to be clairvoyant. Well, there are lots of tests that have been created to verify the claim under controlled conditions so that you are able to tell the difference between a coincidence as an explanation and a real event. And in fact, an event with a known probability. So by convention in science, if you get probabilities that are, say, less than 0.01, less than 1 in 100 odds, then you start saying, well, it looks like it's interesting. It no longer looks like chance.
Okay.
The other way of addressing the question is a theoretical one, which asks, how is it possible, even in theory, for us to understand how something like clairvoyance might exist? And here's where entanglement starts to be interesting, because entanglement implies that the world is much more tightly interconnected across space and time than our eyes tell us. And if, in fact, it is true that even though we don't see it ordinarily, if the world is interconnected, then presumably our brains, our minds, our bodies are also interconnected at some level. And it may be then that simply from a theoretical perspective that our experience, too, our subjective experiences will also be interconnected with the world. From that perspective, when someone describes a clairvoyant experience, it's no longer the anomaly or the unexpected, but in fact, it should be expected in a world which is fully interconnected. So this then provides, this is where the title of Entangled Minds comes from. It's suggesting that by reframing what we think of as the deep fabric of reality, we suddenly see that the whole range of psychic phenomena are no longer something which don't fit into our conception of the world, but in fact not only fit, but are expected. Independent reviews of the methodology of these experiments have shown that they're as good or better than the best experiments typically in psychology.
Okay.
And the reason for that is because after a century of severe skepticism, any scientist who wishes to do one of these experiments well learns quickly the ways of doing a proper experiment, and then going far beyond that. For example, when I do an experiment involving something like telepathy, there's a huge list of things you must do in any ordinary experiment, and then another huge long list that we have to add on to it to be able to nail down all of the usual criticisms.
So you have to try harder. You have to do more.
Yeah, well, and in some respects, it's a valid reason for doing so. That we've learned just from ordinary psychology, for example, that people are biased by wishful thinking, and we're not so good sometimes in assessing whether something's a coincidence, and we're exceptionally sensitive to things like subliminal sensory input. So all of those kinds of factors have to be ruled out in an experiment, and what you do then is when you end up with a positive result in an experiment, you can have high confidence that the result is real.
Yeah. That's what I wanted to ask you is, what about belief? How does belief impact on the outcome of scientific experiments?
Well, an effect was found in the 1940s by Gertrude Schmeidler at City College of New York that she called the sheep-goat effect.
Mm-hmm.
What it refers to is that the sheep, the believers in ESP, tended to get positive and oftentimes significantly positive results in a simple ESP task. And the goats, the skeptics, tended to not simply get a chance result, but get below chance results. So what it suggested, and by the way, this is a fairly robust effect. To this day, people are still doing experiments where they separate out the sheep and the goats, and you can get a predictable split in results. And one of the implications of it is that the belief is a way in which we modulate our openness to experience. So if somebody decides that they're skeptical about any of these phenomena and they become closed to it, which essentially is what severe skepticism is, then they literally can no longer see it. And they may not believe that this is possible, but it's very well known and demonstrated in psychology that the degree to which you're open to a phenomenon, sensory or otherwise, is strongly correlated with your capacity to be able to attend to it.
A great number of people, I've noticed, are becoming aware of the power of intention. So can you elaborate on this?
The power of intention. Well, in the vernacular sense, it's I wish something to happen, and it happens. The way it's studied in the lab is usually more with elementary physical events, like individual random events, which are based on quantum mechanical randomness. Also, recently we've been studying the effect of intention on water, on the crystallization of water when it's frozen.
Oh, yes.
We've looked at the effect of intention between the mind and body, but not your own mind and body, but your mind and somebody else's body at a distance. And in all of these realms, on quantum events, on physiology, on water, we're about to do one on the effect of intention on food, see whether people can tell the difference for food that has good intentions impressed in it versus food that has no intentions impressed in it.
Yes.
In all cases, what we find is something like that the wish or the will or the goal of the person impressing the intentions, that if it's done in a highly concentrated and coherent manner, then something of that seems to be impressed into the substance itself. There are one or two other interpretations of this, so we haven't quite worked it all out. But I think that the link here is that in quantum mechanics there's this thing known as the measurement problem, which refers to the fact that if you observe a quantum system, its behavior will change.
Yeah. Oh, yes.
And so the observation has some kind of an effect on a quantum system. Everything physical that we know of is best described in quantum terms, which means that virtually anything that is observed will change its behavior.
Yes.
Now, if you observe a house, it will change in some way, but its quantum wave function is incredibly complex, and it doesn't give it much room to wiggle. But nevertheless, the theory suggests that, in fact, even experiments can definitely show it at more elementary scales, that when you observe a system, it changes. Now, this is important because the act of observation is usually thought of as being passive. You know, I look at a house. Well, that surely couldn't change the house. But what quantum theory says is that the very act of your observing anything and gaining knowledge about it changes its behavior.
Yeah.
That means that if I observe something with an intention, that the combination of otherwise passive observation and a certain kind of intention underneath it will change the system, so that it raises the possibility that through some kind of observer effect, we can indeed change how a system operates.
Absolutely fascinating. Can I ask you a little bit about the Global Consciousness Project?
Sure. Well, first, the Global Consciousness Project is an experiment that is run by Roger Nelson from Princeton University. It consists of about 70 electronic random number generators that are located in major cities around the world. Each of these are little electronic boxes that fit on a PC that produce streams of random numbers. And the random numbers are based on true noise. So it's not a software algorithm, but a noise-based true random generator. The reason why these are used, and we use these as monitors around the world to see if there's a relationship between large-scale attention in the world and the changes in randomness. So the underlying hypothesis is that at some level, mind and matter are complementary. They're not really different. They're like two sides of a coin and related in some way. In which case, if the mind side of this relationship suddenly becomes highly coherent because a large proportion of the world's attention now goes onto one object, like in 9/11, a large proportion of the world's attention was focused on that one event, to the exclusion of everything else. Well, that's quite unusual from the point of view of the world mind. And so we simply can hypothesize that because of a relationship between mind and matter, that when the mind becomes highly coherent, then perhaps matter would become coherent as well. So the reason we use random number generators as detectors is because a random number generator is by design the most unpatterned device that you can create.
I see.
The statistics are completely unpatterned, in which case if something comes along that would cause it to become orderly or coherent, then it can be detected fairly easily using statistics. So we look for changes in this degree of pattern or degree of order that appears in the random generators around the world. On the day 9/11, we did see a significant deviation in the generators around the world in the direction that we had predicted. They became more orderly. They became more orderly fairly uniformly around the world as well, which is a way, among other things, to see whether or not what we're seeing is an artifact. If all of the generators around the world change in more or less the same way, that's extremely unlikely to occur by chance.
Yeah, something's definitely going on.
Right. And in particular, more interestingly, we were surprised to see that the nature of the order began to change a number of hours before the first plane hit the World Trade Center.
Yes.
That suggests that at some level, perhaps, that the minds in the world had already begun to focus their attention on something, although the something was yet to unfold, which sounds like a large-scale premonition. Now, we've done other experiments since then using the same data to see if we could find other cases where there were these large-scale premonitions. And we did find this. This was work done primarily by Peter Bancel, a physicist in Paris, who's been looking at this data. And what he found was that if you take all of the magnitude 6 earthquakes from the beginning of this project, which was 1998, until now, you can separate those earthquakes by whether they occurred around populated areas or whether they occurred around non-populated areas. The differences tend to be around land masses versus water, but not always. There's some land masses where there aren't many people around. But if you do that, what you find is that for the earthquakes that were around populated areas, that between 2 and 8 hours before the earthquake struck, the random number generators begin to become orderly in the same way that we saw for 9/11, in a quite a significant way. When you'll do the same analysis for the earthquakes around non-populated zones, you don't find anything.
That's interesting.
So what it suggests is that there's something about human awareness that seems to be important in this system.
Of course. So can I ask you, what is the meaning of the woo-woo taboo?
The woo-woo taboo refers to, well, like any taboo, a taboo is either an act which cannot be performed in public or words that cannot be spoken in public. Usually it refers to religious context, but there are many other taboos. There are plenty of taboos that restrict the conduct of science. Besides psychic phenomena, things like homeopathy and cold fusion and astrology and a few others that are very popularly used are taboo in science, and you will not find any articles published in mainstream journals that have a positive spin on these topics, except extremely rarely. And when they do show up, they invariably have a lot of criticism. And that reflects the kind of emotional context that taboos evoke. Normally in science, we think of science as kind of a cool, rational game where anything goes and anything can be discussed in an open manner. But when you find an unusually emotional and irrational response to somebody who is simply presenting something like an experiment, then you know you've touched a taboo. So where does the taboo come from? The taboo in this case, in one way, we might think of it as something that Alan Watts wrote many years ago, a book called On the Taboo Against Knowing Who You Are. And there does seem to be a taboo, at least in the Western world, about asking the question on who and what you are.
Yes.
Part of the reason, perhaps, is that when people do begin to ask these questions, what they run up against is the metaphysics of Western science, in which case the answer to who you are is nothing. That you consist of your brain activity, and even though you have a sense of being aware, it's an illusion, and it has no meaning. And if you think about this, then it's rather frightening. And it's something I suspect that most Western scientists who have completely adopted this model simply don't wish to face. And so this is, I think, one of the reasons why this taboo has arisen, that who wants to think that they're meaningless robots?
Can I ask you, you think outside the box, so has this been very difficult for you?
I think if I had thought of this as being a very difficult thing to do, I probably wouldn't have done it.
Yes.
I'm driven more by curiosity, and by like any explorer, I always want to see what's on the next mountain. That's what drives me, and that's why I'm passionate about this work and why I keep doing it. From a sociological point of view and career point of view, this is not the kind of science that I would recommend that anybody does.
Yes.
It's the sort of thing that you find in a sense like any creative artist will tell you that oftentimes they don't particularly like what they're doing, but their passion pushes them.
Yes.
You're sort of compelled to do it.
Yes, you have to have the fire in the belly.
Right. And sometimes the fire is uncomfortable and you need to take an antacid. So in this case, oftentimes students will ask me, how can I get a career doing parapsychology? And I talk to them for a while to make sure that they think what they want to do is correct. Because sometimes what you'll find is after a couple of years, they'll say, you know what, I'm really disillusioned about all this. What they're reflecting is that they thought, first of all, that it was easy.
Yeah.
And actually, most science is not really that easy, especially science on the edge. And also, they think it's easy in terms of suddenly they're going to become a super psychic and it's all going to be explainable.
Yes.
And if we've learned anything after the past century, it's that we're dealing with a subtle aspect of the mind that we don't really know very much about yet. And thinking of just the power of intention, for example, if intention and observation change the nature of the thing that you're studying, that presents a horrible epistemological problem for any scientist. Because the whole epistemology of science assumes that the thing that you're studying is going to be relatively stable and that it's independent of you. Because otherwise it would be like trying to study something under the microscope that every time it knew that you were looking at it, it flitted away.
Yes.
And so it becomes extremely frustrating after a while because, in a sense, the scientist has to become, in some respect, has to become one with the object of study.
Yes.
Because it's only in becoming the object of study that you can hope to begin to understand it, because these phenomena are not purely objective. They involve subjectivity in some way. Now, when I say these kinds of words, and a conventional scientist is listening to this, they'll think it sounds crazy.
I know.
But the fact is that as anybody who's done even a moderate amount of meditation begins to realize that the mind is a very tricky place. And just like it's very difficult to look at the corner of your eye in a mirror, because your eye moves away the moment your eye moves, it's very difficult to stabilize your mind long enough to realize what is actually going on there. And there's something in there, something deep within the mind that is related to the psychic phenomena and intention and all of the rest.
Can I ask you, have you ever had a psychic or mystical experience?
I've had a number of psychic experiences. I don't think of any greater frequency or astonishment than anybody else, maybe less so even. I haven't had a mystical experience of the classic type. I hope to have one someday.
You will, I'm sure.
I'll give you an example of the sort of psychic thing that happens to me sometimes. My wife and I each have our own PC, and we're reading our email in the living room, and we're positioned in such a way that we can't see each other's screen, and we're reading silently to ourselves. So I get an email from a colleague who is reissuing a book that he had written on déjà vu, and he's going to title it Déjà Vu Revisited. And I thought that was a clever title.
Yes, very clever.
And in the moment I thought that, my wife suddenly looked up from her PC and said, I'm having the strongest déjà vu.
Yes.
And so I thought, oh, this is perfect.
Yes.
It's a déjà vu about a déjà vu. And in this case, I'm able to assess the probability of such an event occurring because in our time together, she has never spontaneously reported a déjà vu at all. And for her to say that at the very instant that I was chuckling in my mind about this makes it a meaningful coincidence.
Absolutely. And for my last question, what would the scientific acceptance of genuine psi mean for ourselves, for science, and for society?
Well, those are three questions.
I know. I thought I'd give you a big one at the end.
The society one is extremely difficult to guess because it's a little bit like asking in the 1950s people who are working on computers, what do you think the societal impact will be of these things?
Yes, of course.
And as we know, what they said was, well, there's probably a world capacity need for 4 of these things, and that's it. Because it's just very difficult to see beyond where you currently are. So I think I'll pass on the societal side. On the science side, well, no, first I'll take the personal side. On the personal side, I don't think it'll make much difference at all. And the reason is that between 60 and 80% of the population believes it anyway.
Yes, that's true.
So it won't change anything. The biggest impact in the short run will be in science. And I think that we're sitting on a dam that's about to burst anyway. Most scientists in private will admit that they're at minimum interested, and more likely they're very interested in these phenomena. Every time I give a talk on these topics to academic and scientific audiences, it's almost always standing room only. And no one will admit why they're there. I mean, sometimes they'll say, well, I'm very skeptical about this. I just wanted to see what you had to say.
Right.
But then afterwards, they come up one by one and they start telling me their stories. So I know that this is a very high interest to people because it's a common human experience.
Yes.
So the change that will occur in science is that once enough evidence, and evidence alone, by the way, is never going to do it. You can have evidence up the wazoo, and it still won't make a difference. What's necessary is for theoretical science to advance to the point where we're beginning to see things like quantum effects in biological systems. And the moment that in fact, we're already beginning to see this now. There's already a number of cases where things like protein folding in biology is seen now as a example of a quantum phenomenon. And when this becomes more popularly known and is published and is considered to be mainstream, it becomes a much smaller step to go into human biology. And from there, it's a smaller step to go into the functioning of the brain.
Yes.
And so I expect that the sequence that will happen is that you'll begin to see quantum phenomena in larger and larger structures for longer periods of time. People will stop thinking about quantum effects as only occurring in elementary systems and in the world of the extremely small, and see it as operating in a much larger scale. And from that perspective, suddenly psychology will have to contend with this possibility.
Yes.
And at some point you end up with entangled minds. At that point, I can predict almost that sometime from now someone will make a prediction about something like entanglement operating in the brain, and then they'll make a speculation about entanglement between brains, and they'll do an experiment and they'll find correlations, unexpected correlations between brains, although actually not unexpected, predicted correlations. And then they'll say, here's the big breakthrough, and they'll get the Nobel Prize. And then someone will quietly say, well, there's actually a century of data that preceded this. And no one paid attention to it. And the reason that they didn't pay attention to it was that scientists didn't have a comfortable way of thinking about these things. And this is not unexpected, actually. Everyone wants to have an explanation for how this can work. And when the explanation starts to evolve, and it's going to evolve faster and faster, eventually it'll all fall into place, and then the textbooks will be rewritten.
Oh, Dr. Radin, thank you so much for coming today. And perhaps you'll come back and tell us more about your fascinating work and more discoveries you'll make.
I'll be glad to.
Dr. Radin is the author of The Conscious Universe, The Scientific Truth of Psychic Phenomena, and his new book, Entangled Minds. Please go to www.merliannews.com to read the review of Entangled Minds. For more information on Dr. Radin, please visit his website at www.deanradin.com. Radin is spelled R-A-D-I-N. This is Merryn Jose, and thank you for listening to merlianpodcast.com.